Okay, and welcome to video 4, and today we'll be talking about angular velocity, and then also moment of inertia, and how this is all in reference to the radius and how it can switch as the radius changes. So first of all, we're going to talk about angular velocity, which is usually written like this, as a W, and its reference is the derivative of theta with respect to time. Angular velocity, let's say if we have a circular path here, and this is the origin, and we have a particle moving around the origin in a circular path, the angular momentum would go along the line, whereas if we were, the angular velocity, whereas if we measured normal velocity, the velocity would be going outwards, whereas the angular velocity is moving around the origin. So the velocity would always be changing, because when we're here, it's moving right out, perpendicular from the line, from its path. Then if it's here, it'd be moving here. If it's here, then it's moving outwards like that. And now, angular momentum is related to velocity by r times velocity, where r is the radius of the circle. And now we're also going to be talking about moment of inertia, which is like what mass is, except for it's like what mass is, but in a rotational sense. So to give you an example of how it can change as radius changes, if you imagine an ice skater spinning around, if they have their hands out like this and move around, they'll go slower, but as they move their hands inwards, they'll go faster and faster and faster. So since we know that now, we'll go on to see how this works in a real world problem. So here we go. Suppose that a spherical star spinning at an initial angular velocity of the angular velocity w, so let's say if this is the spherical star, suddenly collapses to half of its original radius. So if this is r, now we have a star where it equals to r over 2. However, there's no loss of mass, so that means that moment of inertia is changed as the radius decreases, but that means, just like the figure skater, as more mass is compressed into the middle, it will spin faster. So the 4 options that we have here are angular velocity divided by 4, angular velocity divided by 2, no change, and so we know that it increases. So therefore, it can't be either of these or this one. So now we have to decide between these two. But as we see, the moment of inertia of a sphere is so if we apply that, and since r is decreasing, we multiply this, we would come up with that.